Now we're going to take a look at graphing parabolas. So we'll start with the locus definition. So again, this is a geometric construction. And so the idea is that we have a focus point and a line and a point between them. And if we move that point around, as long as that point is the same distance from the focus as it is from the line, then that point is on a parabola. So the locus definition basically says it's the location of all the points that are the same distance from a single point called the focus and a line called the directrix. Now in real life the directrix doesn't really do much. It's a part of the construction for the parabola. The focal point though is actually pretty interesting because it does really give the parabola a lot of function in the real world. For example, if you have a flashlight or maybe a headlight for a car, here's a bulb, of course, and this is a reflector that is in the shape of a parabola. And the light bulb gives off light in all directions. The property of the parabola is that whatever angle the light would hit the parabola, it's going to reflect straight out. So if it hits at an angle like this and hits like an angle like this, as long as it's coming from the focus point, it's going to go straight out. And that gives you a beam of light, a very focused beam of light. We can also work this in the other direction, where energy coming in will reflect off, and regardless of where it hits, if it's coming in straight, it's going to bounce off and it's going to all collect at the focal point. That's what makes your satellite TV dish work. We've got this little sensor here, little radio receiver, that's picking up signals from the satellite. If it were just this little sensor right here picking up waves from the satellite, we wouldn't get very much reception. But we can pick up all of the waves hitting this much larger dish by concentrating them onto the focal point using a dish in the shape of a parabola. So here are the set of equations for the standard form of the parabola. So if you recall, we set up the completing the square to look like this. And the reason that we did that was because now we can see we're going to have a factor that looks like this, y minus k with a squared, if it's opening left and right, as we can tell from the y squared. We're going to have an x minus h in parentheses, and we've moved everything outside that was multiplying the x, so we have x by itself. And that stuff that's outside, this right here, is this 4p thing, and that gives us the value of p. If you look down through the vertex, the focus, and the directrix equations, you can see that p shows up in there as well as h and k. P also tells us if we know that this is opening left and right because it's y squared, we can tell whether it's left or whether it's right by the sign of p. So as we work with these standard form parabola equations, we're going to go ahead and want to make sure that they're set up to look like this so we can pick off the individual parts that we need. So, for example, the left-right parabola that we completed the square for in the previous video. Let's go ahead and write the standard form. Okay, this will be 4p out here, x minus h. And now we can go ahead and assign values to all of these things. Pretty clearly, k is equal to 2. X is going to be equal to -1. And then we have this piece right here, -4, which is going to be equal to 4p. So we can say 4p equals -4. Solving that for p, we're going to get p equals -1. These are the three numbers that we're going to be needing in order to graph this parabola. So the 3 points of interest are going to be our vertex, and that has the coordinates of, I put x there, and what I really meant was h, right? Okay, so the vertex has coordinates of h, -1, and k, which is 2. The focus is going to be located at -2, 2. Now where did we get the -2 from here? The -2 comes from the fact that when we calculate some of these characteristics here, like the focus for example, the x coordinate of this point is actually a formula. It's h plus p. So this part in blue is the x-coordinate, and in this case we have just a single number k, which serves for our y-coordinate. So the focus is going to be at the x value of h plus p, y value of equal to k. So we'll go back here and we'll see that if we apply h plus p, we have h equals -1, p equals -1. Add those two together, we get -2. The directrix line, same idea. Okay, our formula for the directrix line is h minus p. Now we're going to end up with a vertical directrix because we have a parabola that's opening to the left in this case. So if it's a left or right parabola, then we're going to have a vertical directrix. A vertical line has the equation x equals something. So we know that this is going to be x equals, and it's h minus p. So -1 minus -1 gives us x equals 0. So how do we go ahead and use these three things to graph the parabola? Let's go ahead to the graph here, and we can pretty easily plot the vertex. So this is going to be at -1, 2. And then we're going to go ahead and plot the focus at -2, 2. Okay. And then we'll go ahead and draw the directrix at x equals 0. That means it's a vertical line at x equals 0, which of course is the y-axis. Now, does this look like a parabola? It really doesn't. The problem is that we don't know whether the parabola that we want to draw looks like this, or whether it looks like this, or whether it looks like something in between. We know that it opens this way because p was negative, and when p is negative it points to the left, plus we know that the focus is going to be inside the curve of the parabola. However, we don't have any more information about how wide or narrow this is. I'm going to introduce two more points here that I call graph points, and their equations for the x and y coordinates are a little bit more complicated. I've put them on this slide just to kind of keep them handy here while we work with them. So let's look at this one first. In this case, h plus p is going to be -1 plus -1, which is going to be -2. Okay, and then k minus 2p. All right, so k was 2, minus 2 times -1. That gives us 2 minus -2, or 2 plus 2. And so that actually gives us 2, 4 for one of our points. Our second point, we see h plus p is the same for x on both of these, so we don't have to recalculate that. This time we're taking k plus 2p. So k plus 2p is 2 plus -2, which is 0. I'm going to plot those 2 points, -2, 4, and -2, 0. Now with these 3 points, I can sketch a parabola that at least gives me an indication of its size and shape relative to this graph here. I can't really go too much farther beyond here because it's hard to tell, drawing this thing where it's going to go. But for purposes of a sketch, this is good enough. So here's a computer-generated graph of the same thing. If I went back to this, you can see that it looks like everything's pretty much in the right place. All right, let's try this again with an up and down parabola. So again, we came up with this equation from completing the square. And this time we see that we have x squared, which tells us it's up and down. I'm going to write the standard form equation here. Oops, we want 4p here. And then y minus k. And so we can tell now that h is equal to 2. K is -1, and 4p equals 1. 4p equals 1. That means p is 1/4. Okay. So we have a vertex at hk, 2, -1. we have a focus at 2, -3/4. So -3/4 comes from k plus p. -1 plus a 1/4 gives us -3/4. And our directrix, this time since we have a parabola opening up, our directrix is going to be horizontal. And so a horizontal line has the equation y equals, the directrix will be y equals k minus p, which is going to be -1 minus another quarter, -1 and 1/4, and we can also write that as -5/4. So I'll go ahead and plot all these. And once again, we'll go ahead and start with the vertex. The vertex we calculated was at 2, -1. The focus was at 2 and -3/4. So on this graph, it's going to look a little crowded. And just as a interesting point, I guess, the closer you see the vertex and the focus together, the narrower the parabola is going to be. It kind of gives you a little indication from the relative closeness or distance from those. The directrix is going to be at -1 1/4, which is a little bit below 1 here. Okay, so again, that's kind of crowded in here. I want you also to notice that the distance from the focus to the vertex is the same as the distance from the vertex to the directrix. It's the same number, it's just in the opposite direction. Okay, so again, we're going to use these two to get a couple more points to graph with. And so we're going to have h minus 2p. And so we have h was 2, and we're going to subtract off 2 times 1/4. 2 times 1/4 is 1/2, so this is going to be 1 and 1/2. H plus 2p, for this guy here, is going to be 2 plus 2 times 1/4, which is 2 1/2. And then our y value is the same for both of these. K plus p equals -1 plus 1/4, which is -3/4. So the other thing that you might notice is that these points, the graph points, are going to line up with the focus. Okay, so in this case we're going to go to 1 1/2, -3/4, and 2 1/2, -3/4. And we'll sketch our parabola through here. So much narrower parabola that's going through those points right there. Just to emphasize that point again, notice that these graph points here are lined up with the focus. So this one is going to the left. This one we just did is going up. Reason is because p is positive and we have the x squared for this particular parabola. And we can look at the fancy computer generated one to compare. So looks like we're not too far off, got everything pretty much in the right place.